All right, problem 6.6.46. I think this is the last one, at least close to it, for this lesson. So they give us this model that we're supposed to use. I see that at first glance. It's professor conducted an experiment to find the relationship between time and memory. The professor determined that this was the model that represented it, that f of t, in case you can't read that very well, I'll rewrite it here, equals t sub 0. That would make me think it's like the initial one, the initial time maybe, minus 15 times the log of t plus 1.1. So that gives the memory score after t months. So t0 may be the initial month when a student had an initial memory. So over here, they give us the specific point, 0.94. And so if 0 is the t and 94, so let's just see what that works. If t is 0, let's see what this t0 is. And this comes out to 94. So if you're going to solve this for t0, we're going to add this whole thing here on to the 94. So that would tell us what t0 is. Then we can plug that into the formula, the blue formula for t0, and that would give us our actual equation here. So again, I'm going to just jump over to Desmos to demonstrate that, but I'm going to be adding the 94 plus the 15 log, and 0 plus 1.1 would just be 1.1. So let's see here. Let me find Desmos available. Share that with you. And again, we're just doing the 94 and add to it 15 times the log. It's base 10, so we don't need to put anything in there of my 1.1. And then that gives me this 94.62089 number. So as long as I copied that, so write the model for this. So it wasn't exactly the 94 for the formula like it looked like. So all right, so hopefully you're seeing back our problem here. So when it says write the formula in here, what they're wanting right here is, and then it says integer decimals round to the nearest hundredth. So that's 2 places. So we're going to put that, remember this number that I got when I subtracted this was for the t0. So my formula f of t equals to the 100. So it's 94.62. That's my t0 minus my 15 log of t plus 1.1 for this person. Okay, that's in the graph. Then after about how many months will the student have a memory score of 80? So now with this, that's your answer. So they want to know, when will 80 equal this formula? So if we have this equation, how do we solve to get that t alone? So first we're going to subtract the 94 over. So I've got my 80 minus my 94.62. And if you want to be precise, keep all the decimals for this that we had. That would keep our answer more exact. And then only round to the nearest whole number in your final step, that would give you a little more exact answer. So once this is gone, we've got negative 15 times this log. So then I'm going to divide by that negative 15 to get that off from there. So all this is divided by the negative 15, and that'll equal my log of the t plus 1.1. I think we've said it before, you know, if there's no log written there, this is log base 10. And once you get a log and your variables in this argument, expression, parameter that's being taken the log of, that's your cue to write an exponent problem. So after this, you're going to have your base 10. This whole thing becomes your power. So that 80 minus 94.62 number, and if you've got that in a calculator or something, that would be even better. And it equals your t plus 1.1. So then after that, when you subtract this 1.1, you'll have your t. So to do all of that for that problem, again, my preferred way to do that, and you could do it one piece at a time, but I'm going to end up just doing it as I wrote it out there, the 10 to the 80 minus 94.62 number all over the negative 15. And then after I hit equals and get that answer, I'm going to subtract 1.1. Let's see how it looks if we enter that in Desmos. Again, I had 10. If I copied this down on my paper right, to the power of, in the numerator, I had 80 minus, I copied that long number there earlier. And then that was over slash divided by my negative 15. And then outside of that whole thing, I had a minus 1.1. So I've got 8.33, and I believe, if I remember right, it said round to the nearest whole number. Kept all my accuracy there, notice, so whatever accuracy they needed. So I think it said round to the nearest whole number. So then I would have, for my final answer on this one, 8 months. Good luck.